random samples need to be independent of each other, right? That's a different issue than the independent within the group. And then what's our third one? What's the third one? Normality. But now it's like you have all of these things, and they all should be bigger than 10 to assume normality, yes? Are these checkable? Can we check N1 versus P1? Do we know what P1 is? No. In the one proportion test we did when we were doing a hypothesis test, right? Because we looked at the null. Does this one tell us what P1 is? No. So we can't really check this, so what do? Right, we're going to use P hats here, are we not? Again, we want to use P's, but we can't, so we're going to use P hats. All right, now let's figure out how to do this. Anyone have an idea? Euro does. Who else? Fausto does. Go ahead, Fausto. What do we do? Go ahead.
Why are you using P1 instead of control?
Over here, because it may not be control and experiment. I'm just doing it in general. In this particular case, it's control. Well, look, I need some number. Because I got to put something in the middle, right? I got to make a conditional probability to get my p-value. You really should see what to do. These two see it, but I would really like more people to see what to do. Like Daisy here. I'd like her to see what to do. I'd really like you to just think this through about what should I do with these null hypotheses. Right over here, it's kind of obvious, right? I'm going to say, okay, I'll assume P is 0.25, and that goes in the middle of my sampling distribution. But what can I do here? Because we've done it before. When we talked about differences. Now I'm getting a few more people to nod their heads. Michaela, do you have it?
I think so. Like, you do, like, P experimental minus control.
She said subtract. Is that what you were going to say? Is that what you were going to say? Is that what you were going to say? Subtract is the answer. Rewrite these null hypotheses as differences. So P experimental minus P control equals what? Equals what? 0. There's my number for the middle of my sampling distribution. P experimental minus P control equals, is greater than 0. That's the solution to all this. Now, here is a sampling distribution. But it's not a sampling distribution of P hats, like it was in the previous chapter. It's a sampling distribution of what? Of what? Hat, right? It's the difference between P.
My god.
What's wrong?
That scared me.
Me too.
I spat.
I was like, am I hearing things?
Yeah, me too. I was like, I heard this, and I was like,
It's,
what
wait. If we did an experiment, if I do an experiment, I get P hat control and a P hat experimental, right? And then I subtract the two. But if you do an experiment, you're going to get a different number, aren't you?
Yeah.
Okay, over and over again, we're going to get different P hats. Each time we could subtract the two P hats, and now we have a sampling distribution of all the P hats. Excuse me, of all the difference of P hats. Okay? What should I call the middle of that sampling distribution? What's the right notation? Mu of P hat 1 minus P hat 2. That's the middle of it. It's averaging out all possible differences. If we did this randomly, what should that equal? How about P1 minus P2? And so that's this first assumption, is that mu P hat 1 minus P hat 2 equals P1 minus P2. But what is the null telling us about P1 minus P2? What is the null telling us about it?
Zero.
That there's no difference, right? So I'm going to put what in the middle here? 0. And now I'm going to find out what my results were. What were my particular difference of P hats? Point what? Right? P hat experimental minus P hat control is point, help me here. What was this? 3.8 what? This was 3.85? So 0.044, is that right? Did I do that right? So here's 0.044. I did that wrong? He's saying it's 0.01.
No.
Okay. I have never been good at math, so. Good. Do I need to shade the other side or not?
No.
Okay. Now I should just calculate a what? I'm almost done. What should I calculate? Z-score, right? Z equals, what's in my numerator? Point. Okay, minus 0, right? Now look, Mama Stein didn't raise no dummies. I am aware that when I subtract 0, that's not changing anything. And I could just put P hat 1 minus P hat 2 up there, right? But why am I writing that minus 0?
Like a Z-score.
I'm trying to focus on what I'm doing. Right? I'm saying, here's the center, here's what I'm trying to calculate the probability of. Okay? Now I need a standard deviation. Who knows how to find it? Go ahead.
Normally it's just but
Okay, we learned that before, didn't we? If the two groups are independent from each other, which is why we need independent between groups, then we can just find their two what? How do we do it? Variances and add them together. If they're independent within the groups, each variance is square root of, what's the formula? PQ over N. So there's one of them. That's independent within the group. Then there's
oh yeah, it is. You see, it was
this one, which is the other one. And now what do I have to do? Find the variances and add them up? Is that just the formula I need here? So the formula should be square root of P1 Q1 over N1 plus P2 Q2 over N2. Yes? And that's what we need. That's why we're checking that second assumption. But now we got a problem. What's the problem? We don't know P. With the one proportion, we went to the null hypothesis to get it, right? But here we have a problem, which we are not assuming a value for these two P's. We're just assuming that they're equal. We don't have a number to put here. I know what you want to do. I know it. Because it's what we have done up till now. What do you want to do? You want to do what? I don't want to do 0.5. 0.5 is the worst case scenario. I don't want to do that. But I want to, okay, so who says I should do this? That's what we have been doing whenever we have this problem. We're not going to do it here. Because that's wrong. Anybody see why it's wrong? This is a logic question. What are we assuming is true in this problem? What are we assuming is true? Yeah, but we assume the null is true, right? What does the null say about these two p's? What, Caleb? That they're the same. If I go in and put different numbers here and here, isn't that like internally contradictory? I'm violating the assumption that I'm making for this whole problem, the overriding assumption. I gotta put the same number here and here. But I don't have a number to put. What? Good idea. Maybe what I should do is take p hat 1 plus p hat 2 and average them. That's reasonable, but we don't do that. But it's close. It's way better than using the two individual p hats, because now I'll have a number. But can you see why that's a bit of a problem? What if this had like 200 people and this had 20? Right? If I'm averaging them equally, I'm ignoring the fact that these sample sizes might in fact be different. Because what I really want to say is, okay, what is this proportion if they're equal? Right? And so if I average them equally, and this has way more people in it, I'm giving much more like weight than I should be to this group. Yes? Do you hear what he just said? This is the answer to this problem. And I really want you to think about what I'm trying to do here. I'm trying to find a reasonable number to use for the two p hats that's the same number. And we call this number, what he just suggested, p hat pool. Okay? And p, this is just another, the horrible thing about statistics is that everything's p. Okay? So this is p hat pool. Okay, and what it is, what is he describing in math? What is he describing? A weighted average, right? So what did you say? Go ahead.
N1,
Yeah, honestly.
No, N1 P hat 1 plus N2 over, okay, but that simplifies. What's N1 P hat 1? (30/78), right? Times what? 78, which is just 30, which is the number of successes, isn't it? Isn't this the number of successes? So this reduces to this. Now, why is it called p hat pool? And Keith, just stay with me. Why is it called p hat pool? Do you see all we're really doing is saying, okay, let's just assume P doesn't, it doesn't matter which group you're in. But that's what the null says, is it doesn't matter which group you're in. So we just pool them all together. 58 over 160, isn't that right? This is called p hat pool. Sometimes I call it p hat stupid because it's like, not because it's stupid, but because it's like the stupid way to add fractions.
Oh yeah,
Right?
sure.
Like we don't add fractions that way, adding the numerators and adding the denominators, but this is how we're doing it in this case. So it's not the sum of these two p hats, right? It's pooling the two p hats. And what I want you to see is what I'm doing and why I'm doing it. And now I'm going to put that number in for both P1 and P2. So what would it be in our case? Give me a decimal, please. It would be 58 over 160.
I get that. Did you take a picture of that?
0.35.
I just don't know if I
0. Okay.
recognize it.
Now,
Coherent.
if the two sample sizes are the same, what Fausto said is right as well. Right? This will just come out to be the average of these two numbers. Okay? And you can see it's about that because they're close to each other. So now I'm pretty much done. Square root of 0.35